Hello, today we're going to do section 10.2, Applications of Quadratic Equations. The objectives of this section are to set up and solve word problems involving quadratic equations, the Pythagorean Theorem, and rational equations that result in a quadratic equation. Quadratic word problems, like the quadratic equations that model them, often have a pair of answers. As a result, there's usually one answer that doesn't make sense in the context of the problem. Example 1. A 17-foot string of lights will be attached to the top of an 8-foot pole for a holiday display. How far from the base of the pole should the end of the string of lights be anchored? Well, we got an 8-foot pole with a 70-foot string of lights, and we're asking how far from the pole to where the lights are anchored must the stake be placed. So we're looking for x, and because this is a right triangle, we can use the Pythagorean Theorem. Which says a squared plus b squared equals c squared, where a and b are the two legs of the triangle, and c is the hypotenuse of the right triangle. So in here we get x squared plus 8 squared equals 17 squared, which is x squared plus 64 equals 289. Well, now because this is quadratic, I need to get 0 on one side, so subtract 289, subtract 289. We get x squared minus 225 equals 0. Now, x squared is a perfect square, so you might be wondering, is 225 a perfect square? And it is. It's 15 squared. So this is a difference of squares. So we get x minus 15, x plus 15 equals 0. So x minus 15 equals 0 means x equals 15. And x plus 15 equals 0 means x equals negative 15. And this is what I was talking about. Because x is representing a distance, negative doesn't make sense. So x equals 15 feet is the solution. Example 2. A rectangle has a perimeter of 200 meters and an area of 2,400 square meters. What are the dimensions of the rectangle? So again, I'm going to start off by drawing a picture. So we have a rectangle. I don't know what the either dimension is, so I'll just say x and y. Well, the perimeter of a rectangle is adding up all its sides, so 2x plus 2y. And the reason for the 2's is because there's 2 widths and 2 lengths. And that has to equal 200. And then the area of a rectangle is length times width, so x times y equals 2,400. So we have a system of equations. So we're going to use the substitution method to solve it. Let's take the first equation and solve it for y. So subtract 2x, subtract 2x. 2y equals negative 2x plus 200. Divide by 2, divide by 2. Y equals negative x plus 100. And now substitute that into the second equation. So we get x times negative x plus 100 equals 2,400. Distribute the x, we get negative x squared plus 100x equals 2,400. Then I'm actually going to add x squared and subtract 100x from both sides. That way my x squared is positive. So then we get x squared minus 100x plus 2,400 equals 0. So now a times c is 2,400. I need to find two numbers that multiply to 2,400 but add up to negative 100. That might take a while. 2400 does have a lot of factor pairs, but after you check it out, you'll see that it's negative 40 and negative 60. Because negative 40 times negative 60 is 2400, and negative 40 plus negative 60 is 100. So that we get x minus 40 equals 0, and x minus 60 equals 0. So x equals 40, x equals 60. So both of them are positive. They both make sense, which kind of makes sense because if you think about it, if you take a rectangle and rotate it 90 degrees, you get the same shape, but the length and width have swapped positions. So here, how I drew it, x is the smaller one. So x will be 40 meters. And then y will be the 60 meters. And you could take that and plug it back into y equals negative x plus 100, but you'll see that it comes out to be 60. Example 3. The product of two consecutive integers is 210. So remember, consecutive integers means that we have the first integer is x, then the second integer is one more than that, so x plus 1. So when I say the product of two consecutive integers is 210, that means x times x plus 1 equals 210, which gives us x squared plus x equals 210. Subtract 210 from both sides. X squared plus x minus 210 equals 0. Now I need to find two numbers that multiply to 210, negative 210, and add up to 1. After a while, you'll see that it's x minus 14 times x plus 15 equals 0, because negative 14 times positive 15 is negative 210, and negative 14 plus 15 is 1. So then we set those each equal to 0. And we get x equals 14, or x equals negative 15. Now here, there are no restrictions, so both of them will make sense. On Newton, be careful. Sometimes they'll say the product of two positive consecutive integers, in which case you'd have to choose 14. But because of this, if x equals 14, then x plus 1 equals 15. If x equals negative 15, then x plus 1 equals negative 14. So you get 14 and 15, or negative 15 and negative 14 for this answer. Example 4. Jean kicked her soccer ball up in the air with an initial velocity of 30 feet per second. It lands on a flat roof 9 feet up in the air. If the acceleration of gravity is 32 feet per second, then how many seconds after Jean kicks her ball does it land on the roof? And we have this formula, h equals negative a over 2t squared plus v naught t plus h naught, where a is your acceleration, v naught is your initial velocity, and h naught is your initial height. So then for this specific problem, we get h equals negative 32 over 2 t squared plus, well, the initial velocity was 30 feet. And don't make the mistake, the initial height wasn't 9 feet. That's where it ends. The initial height, since she's kicking it from the ground, is 0. So then if we just simplify that fraction, we get negative 16t squared plus 30t. Now, that doesn't answer the question, it just gives us the formula. To answer the question, we need to figure out at what time does it equal 9. So if we have 9 equals negative 16t squared plus 30t, let's solve for t. So I'm going to add 16t squared and subtract 30t from both sides. to get 16t squared minus 30t plus 9 equals 0. Now we have to factor this. Don't forget to check for the GCF. I haven't been in this note section yet, and this one again doesn't have a GCF. So this one I don't know off the top of my head, so I'm going to go A times C, which is 16 times 9, which is 144. And then we need to add up to negative 30. So when I do my factor pairs, I need two negative numbers. So negative 1, negative 144. Negative 2, negative 72. Negative 3, negative 48. Negative 4, negative 36. 5 doesn't work. 6 works. Negative 24. And I'm going to stop there even though there are more, because this gives us the negative 30. So we get 16t squared minus 6t minus 24t plus 9 equals 0. Can take 2t out of the first one. So then we get 8t minus 3. Then I can take a negative 3 to get 8t minus 3. So then we get 8t minus 3 times 2t minus 3 equals 0. So 8t minus 3 equals 0. Add 3, add 3. 8t equals 3. Divide by 8, divide by 8. T equals 3/8. Then we get 2t minus 3 equals 0. Plus 3 plus 3. 2t equals 3. Divide by 2, divide by 2. T equals 3/2. So we get two answers, but I'm pretty sure there can only be one answer. So we have to think about this a little bit. Let me move these down. So if you think about what's happening, there's a building here with a roof. We're kicking a ball, and if the ball goes on the roof, that means it goes in this. So the height of the roof is 9 feet. So if you look, the ball reaches 9 feet, then it goes over and then lands on 9 feet. That means the second time it gets to 9 feet is when it's on the roof of the building. Well, 3/8 is less than 1. 3/2 is more than 1. So the second time is 3/2. So t equals 3/2, or 1.5 seconds. And then example 5. In 2 hours, a motorboat can travel 8 miles down a river and return 4 miles back. If the river flows at a rate of 2 miles per hour, how fast can the boat travel in water? I'm hoping that you recognize this as uniform motion. So if you remember, from chapter 6 when we did these problems, we used D equals R times T. And then we are going upstream, downstream, and it does give us some totals. So in 2 hours, the motorboat can travel 8 miles down a river and return 4 miles back. So the 2 hours is the total time. 8 miles down, 4 miles back, so we get a total of 12. There never will be a total speed because you can't add speeds together. Okay, and if the river flows at a rate of 2 miles per hour, how fast can the boat travel in still water? Now this is where you have to remember what we talked about before, where we took the speed of the boat minus the speed of the river when we're going upstream. and then the speed of the boat plus the speed of the river when we're going down. But here, the only unknown is the speed of the boat. I know the river is 2, so going upstream will be x minus 2, and going downstream will be x plus 2. And then to get our time, if I know d equals r times t, then t equals d divided by r. So this time will be d divided by r, so 4 over x minus 2. And this time will be d divided by r, so 8 divided by x minus 2. Then the last column gives us our equation, x plus 2, not x minus 2. So we get 4 over x minus 2 plus 8 over x plus 2 equals 2. So we get a rational equation. So the first thing we have to do is multiply by the LCD to clear the denominators. Well, for this problem, the LCD is x minus 2 times x plus 2. So I'm going to just multiply everything by that. So for the first one, the x minus 2's cancel out. And then 4 times x plus 2 is 4x plus 8. For the second one, the x plus 2's cancel out. And then 8 times x minus 2 is 8x minus 16. Then nothing cancels out here. So let me just simplify this before I go up there. X minus 2 times x plus 2 is our difference of squares. So that will be x squared minus 4. And then distribute the 2, we get 2x squared minus 8. Okay. Now I'm going to combine like terms. We get 12x minus 8 equals 2x squared minus 8. Then I'm going to subtract 12x and add 8 to both sides. $12x is on the left, cancel out. The 8's on the left, cancel out. The 8's on the right also cancel out. So we're left with 2x squared minus 12x equals 0. Now this is where we are going to use the GCF. I can factor 2x out. So then we get x minus 6 equals 0. So 2x equals 0 and x minus 6 equals 0. Divide by 2, we get x equals 0, or add 6, and we get x equals 6. Now, since x is representing the speed of the boat in still water, x equals 0 doesn't make sense, so we get that this boat can go 6 miles per hour. And that's it for section 10.2.